Hey, sixth grade, make sure you are on this page of your notes where it's titled Shapes of Distribution. So it's not talking about the distributive property, because I know that this sounds very similar to that, but we're talking about stem and leaf plots, histograms, line plots, dot plots. We're looking at shapes of data to see what that can tell us. So I'm going to go back to my notes from your histogram, the notes you did earlier, creating histograms. And this data, see how there's a trend? This is actually telling me something, and there's a name for this way the data is shaped. Same with my practice on the other side. It's not a complete trend. There's a little up and a little down, but there's a way to describe what that is using mathematical language. So first I need you guys to put the distribution of a data set is the description of the overall shape. So kind of which way does it flow? Is it going trend going up? Is it a trend going down? Is there a bunch of random peaks? Are there clusters of data? That kind of thing. The data can be skewed or normal. Now, skewed means it's leaning really far one way or the other. Has anyone ever been in a kayak or a boat, and if everybody sits on one side, it's skewed, it's going to tip over? Almost that sort of thing. Going back to this example, see how all of the numbers are kind of on this side? It's more heavy on this portion of the histogram. That's what a shape is, or if there is a skew in the data. Whereas this one, see how it's kind of more intervals are going up and down? This might not necessarily be normal, but it's not as skewed where everything starts trending in one direction or the other. Skewed data sets have a majority of the data on one side of the peak. Remember the peak, that's the highest point in your data. So if it's leaning mostly to one side versus the other, that means the data is most likely skewed. Normal distributions are symmetrical. Like if I took the data and I folded it in half, it would be nice and even. Also, you will see data, maybe like an example of symmetrical data, something like this. Going up and down. This is actually called, in science, this is called a bell curve. If you see how it looks kind of like a hill, where it starts and where it stops kind of is more symmetrical. This is kind of more along the lines of what you're doing. And make sure you please draw this so you know kind of just a rough idea. Kind of looks like a weird like sandcastle, or if you put blocks together in a shape. This is we considered normal, not skewed. Data sets that have a negative skew can also be called skewed left. Please put an arrow at left. If a data set is skewed left, the tail of the graph extends to the left. And most of the data is on the right. Okay, Miss Madera is going to stop for a second and tell you why I don't like this. Basically, you're going to jump back up here because I want you to actually write this. I want you to think of opposites. Now, I'm not talking about the opposite of -1 is +1. The opposite of -20 is +20. I'm talking about if it's saying it is skewed left, that means most of the data is on the right. Literally the opposite of what I just said. It's skewed left. That means, like, I'm going to go back to this one. This data is skewed left because most of the data is on the right. Think of whatever is skewed. It's the side that's missing something. It's the side that's the least, the side that's without. See how it's mostly on the right side? That means this is skewed left. The tail of your data is on the left. So, going the other direction, if a data that has a negative skew, that means the mean is on the left side of the peak, the center of the data. Data sets that have a positive skew can also be called skewed right. So if the data set is skewed right, that means the tail extends to the right, and most of the data is, guess where? On the left. Now this is just to fill in your notes, and then I'm going to show you more clearly down here. This is going to be your go-to cheat sheet. If they're asking about shapes of distribution, what you would study or practice is this stuff right here, which I'll get to in just one moment. I'm going to go ahead and finish up on my notes. I'm on number 10. In a data set that has a positive skew, the mean is on the right side of the data. So just make sure you have all these pieces. So looking at this, oh, that looks a lot like a drawing I did earlier because this is considered symmetrical. See how the peak is pretty much in the middle? It's got nice, it's pretty symmetrical, kind of even on both sides. Kind of looks like a pyramid almost. This is considered normal. It is symmetrical, it is normal. That is what I would describe this shape of the distribution. Okay. Now, I'm going to go here. Here's my peak. See how this one's the tallest? I'm going to label this my peak. And then the lowest portion, it actually does have a name. It is called the tail. Statistics is so strange. We got stem and leaf plots, box and whisker plots, so many strange things. We got peaks and tails. I don't know what to tell you, but we're going to go with it. So since the peak is over here, this is on the left side. I'm not going to say, because it's heavy on the left side, this is considered skewed right. See how it's heavy? This is your left and your right. If you're not sure, do the L shape. The L you actually make is the left because it's really heavy. See all this really tall piece of the histogram on the left side? That means it is skewed right in that direction. And if it's skewed right, it's already a positive skew. All right, looking at the last one, see how, oh, I got a little dip here, but that's okay, even though it's not a perfect, looks like a staircase just going up and down. Even though there is a little bit of a drop here, the majority of the data is over on the right side of my histogram. So because it's on the right heavy side, that means the opposite, it is skewed left. So think, if you want to see which way it is skewed, look at the place where there is data missing or it has the least. That might be a better, more easy way to figure out what is the shape of the distribution. Again, if it is skewed left, that means it is a negative skew. Think of it this way. Numbers on the left of the number line are negative. Numbers more right on the number line are more positive. So I'm going to have you guys please write this on the bottom of your paper. I'm going to use a different color. The skew of the data is in the direction where the tail or data is the least. Okay, I've been covering that up while I'm talking, so make sure you get that on your paper. I'm sorry to cover that up while I was explaining that. When you are ready, go ahead and turn your papers over. I'm going to get you guys started on one of the problems. This is your cheat sheet right here. This is the chunk of your notes that you do not want to be without. This is just explaining what this is and more detail about symmetrical data, shapes. So you're looking at this, and all I want you to know is, all I want you to tell me is it normal? Is it skewed right? Is it skewed left? That's all you need to tell me. So I'm actually going to help you with number 5, and then you will do these other problems on your own or with a partner. So I'm going to look at this. I'm going to create a line plot of this data. So it could be a histogram or a line plot. So let's see. I got 30. I'll do X's. I have another 30, 25, 20, 15, 25, 30. Oh gosh, I'm making X's over here, making X's over there. Goodness gracious. Another 30, another 20, and another 25. Okay, there is my data. So I'm going to use another color. You do not have to draw this, but you can. I'm noticing a trend going upwards and then back down very quickly. I'm noticing it's very heavy on the right side of my data, which means that it is actually, I'm going to change my color again. I would say this is skewed left. And then I'm going to go back to my notes and think, wait, what is skewed left right here? That means a negative skew. I want this whole answer right here completely here. So you have to say skewed left and a negative skew or shape. That's what skew means, is which shape is it shifting. So what you guys are going to do on the, make sure you have all this. And after you have that, make sure you go to the other problems, and you're going to need to tell me either it's symmetrical and normal, it's skewed right with a positive skew, or it's skewed left with a negative skew. I need this whole answer in your group work. Once you have completed that, you may move on to the next task.